glacier. So there can be regions where snow is falling down, and that can be in regions of mountains, and there now a glacier can form. There can be a little high plateau of a mountain or something, and then snow accumulates on it, and more snow is falling down onto it from a little higher peak of the mountain, the Berggrund, and where it goes down, it presses in and makes a rotational slip, and through abrasion and erosion, it creates a deeper hollow area. And when it's going over the lip then down, and as a glacier it is going then down, even lower is the snow line. So the region where permanently is snow, even lower is now the glacier ice flowing slowly down, very slowly, only a meter a day or something. And it can be kilometers long, so it can take many years, decades even, if it ends at the end. Some people have lost things in it, and they took them decades to come down again. And there they can form, and they can make erosion to the mountain, they can make plugging, they can freeze onto a rock, and then the glacier moves and rips it up, and where the rock can scratch over the ground, making abrasion to the ground, and also freeze and thaw. Some water can come into a crack, and when water is freezing, is changing the state from being liquid to frozen, it is expanding and cracking then the rock. And when more rocks going with it, all the rocks transported with it are called moraine. If they are very fine, they're called rock floor. And they are then going down and ending then as a terminal moraine at the snout of a glacier, maybe as a drumlin, a low hill, or as a rocher mountain, but that is not a moraine. A rocher mountain can be there. There is the glacier going over, or the ice sheet over a rock, making scratches into it, making it smooth on one side, and on the other side it is ripping away parts of the rock. And the lateral moraine are the rocks at the sides. Medial moraine, some two glaciers can meet over along another mountain, and making then medial moraine and the ground moraine at the bottom. There were ice ages. For example, one was 15,000 years ago. There was Europe covered with ice sheets, and the northern part of England, for example, in the book used. And there were then boulders, big rocks, even transported with the ice many kilometers away, and also with different materials laid down in different places. And different areas of the country consist now out of these materials brought there, and where some cliffs are existing out of it that is eroding differently because it is material brought there with glaciers. And there can be also fjords. By a fjord there was a valley which has been digged deeper through a glacier over thousands of years with the erosion, and now the glacier was lying deeper as the sea level, and now the water is flowing in it after the ice has melted and the ice age had ended, and now the water is standing in it, a very long, maybe over 100 kilometers long, but narrow valley, just 5 kilometers wide, all full of water, deep also. There can be also ribbon lakes. There's some water standing in such a valley, and the moraine, all the rock material, are lying next to it, a very long but very narrow lake. So all the glaciers starting from the quarry, where now, after the glacier is melted, a tarn lake can be in, maybe separated the two sides of the mountain, if the mountain has two glaciers through a reed, and there the glaciers going down there into the valleys. And better glaciers. According to Geography by Jane Ferretti and Brian Gressleigh, on the pages 22, 23, 24, and 25. The positions and views expressed are the ones of the source and don't necessarily align with my own or with the ones of the entity spoken.
Hi and welcome. I'm trying to learn glaciology. Today, a glacier, and after I've done what we're going to do, stretching. And if you participate in the stretching, then it's better at your own risk. A glacier. Let's just start with the topmost thing. Freeze for action steepens the back wall of a corrie. Okay, there's some corrie, and because it's freezing and then thawing again, it steepens it. At the back of a corrie, the ice pulls away from the mountain at a single crevasse, calling a Berggrund. Okay, so the corrie seems to be the topmost part of the mountain. And there's the ice pulling away at a crevasse, which is, I don't know completely, it is a cliff in a mountain or something. And that has been called, because the glacier is pulling at it, a Berggrund. Layers of snow and fern develop each year. Fern, did they say it was snowflakes that snowflakes fall and refreeze and form a whitish grain-like snow called firn. So firn is refreezed and formed again snow. Okay, there's a layer of snow and firn at the top. Rotational slip as ice moves out of Cori. Okay, let's start to read the other one here. The starting point of a glacier is a hollow high on the mountainside called a Cori, cirque, or CWM. But I think it's a word. Snow and ice gather in the hollow, which gets larger through freeze and thaw, abrasion, and plucking as the ice begins to move in a circular motion called rotational slip. Okay, first there's a little bend in the mountain. The mountain is not going straight through or standing, it is a little hole in it. And where ice accumulates in it, and then from the top, there's more coming into it, pushing it then out. And over time, it's going greater and bigger. The ice moves out of a Cori, and the thing is called a Cori. The ice moves out of a Cori over the lip of a hollow formed by a rotational slip and down the mountainside. Okay, it is just lying in there, but more is sliding into it, and it presses it out, and it makes it deeper and deeper. Number 3. The mass of ice moves as though it were a very stiff liquid, slowly oozing its way down the mountainside. The flow can reach speeds of 4 meters a day. People and aircraft lost in the ice have been found at the bottom of a glacier years later. Okay, they're saying it is flowing down, but very slowly. By saying 4 meters a day are possible, but it can be also less. And there were some accidents where planes were in mountains and glaciers, and also some people, and they came when out years, decades, or even later. Number 4. The glacier ice moves by sliding over the underlying rock on a film of water and by plastic flow within the glacier. So it is sliding on a film of water. Is it necessary and always the case? There is oftentimes a film of water between it and it's sliding on the little water. And plastic flow, I think they mean now water running inside the glacier at some little areas. Number 5. The surface of a glacier is a brittle crust with cracks into deep crevices. I don't know how to pronounce it. Crevices. As the glacier moves over bumps and drags against the valley sides. So I think these cracks, these little, so it's not a firm ice, but it's cracking, is when it goes over bumps. And that makes sense. If there's the glacier coming and there's suddenly a bump, then it has to go up, and now it's cracking the ice. Where steps occur in the mountain and ice fall forms. Steps occur. Here intense crevassing forms enormous blocks of ice called seracs, which often topple into a chaotic jumble. Okay, there is a lot without illustration. There can be a step in the mountain. So we're saying the mountain is going like that, and suddenly there's a cliff, I guess. And there's an ice fall. And an ice fall is? Here intense crevassing forms enormous blocks of ice called seracs. I think one part is behind the cliff, another one over it, and that is now a big block. Which often topple into a chaotic jumble. And these blocks are standing together, but they're loose from the other blocks, and that means if a glacier goes on, they can topple over. And number 6. As the glacier moves downhill, it will erode the valley down which it is traveling by plucking and abrasion. The rocks carried in the bottom of a glacier are called the ground moraine. Okay, it is forming a greater valley. It is making the valley bigger by going over through it. And the rocks carried when within the glacier, which just takes slowly with it. We have in the previous part of the erosion, the ice freezes with it and takes them with it, for example. They are called ground moraine. 7. As the glacier reaches lower levels and the climate is warmer, more ice melts. Rock debris which has been carried inside the glacier moves to the surface as moraine. Okay, the ice is getting thinner, and it comes more to the appearance with its stones in it, the moraine. 8. At the end of the glacier is the snout. Okay, we call it snout. It may stay in one place, but ice is constantly moving to this point and then melting. Okay, the snout is oftentimes at the same place. Why is it so much at the same place? It is depending on the temperature, but it is lower down in the valley, but I think also the geological position has to have an influence on it. But it stays there at that place. At that place, is it there going slow? Why is it oftentimes so constant where this last place is? Okay, at some place there's no ice anymore. New ice is still sliding to that place, but as soon as it reaches there, it gets thinner and thinner, and it reaches at that one place when more or less it's at. The meltwater stream carries debris away from the glacier snout, depositing it as terminal moraine across the land below. Why is it called a terminal moraine if it's still so high up a mountain and will go further? Okay, the meltwater streams of the water coming out of it, the ice having melted down, becoming meltwater stream carries then the rocks, the moraine with it, and it keeps them to lie. It starts then to lie at some place as a terminal moraine. Erosion. As the glacier moves downhill, it will erode the valley by abrasion and plucking, smoothing away ridges and deepening the valley. Transportation. The glacier will carry a large amount of rock debris known as moraine. This varies in size from rocks as large as a house to powder called a rock floor. Okay, these rocks can be big, like a house, or very small, powder, and then called a rock. Is it flour? Most of the load is never the glacier base, is near the glacier base. If the glacier base goes further in front or further back, does that have a big influence on the total volume of the glacier? Or is still the greatest amount further in front of the... The question is basically, if the topmost 50 meters get bigger or smaller, is then also proportional the 50 meter of the biggest part of the ice of the glacier gone, or is it just further back or further in front? If the 50 meters of the part where the most of it is missing is somewhere else, is then the part with 50 meters of most of it as the volume missing, or just the regular 50 meters is somewhere of the total length of the glacier? Deposition. At the snouts, the ice melts and its load is dumped in piles or washed away by the meltwater to be deposited over the lowland. In piles, I don't know what piles are. Oh, okay, whatever. The terminal moraine ends where the rocks. The illustration is quite good. That was for glaciology. If you were here for glaciology, you can go directly to the next part. Then we'll continue with glaciology, and we'll go back to that page and make a presentation and say how such a glacier is moving. If you stay here and participate in the stretching, then it's very honest. Have your feet standing together, out with one foot to the side, and then with the other. And so on, as far as you can go. And in. This time, stay down in the knees. And up. Legs to the sides, lifting the arms up. And out to the side. In middle. Out over to the other side. In. And out, slide with one arm down the leg. Relief in. Out one arm over. Relief in and open the rib cage. Out and back. Relief again in. And out the other arm slides down. Again in. Out one arm over. In and out the rib cage. Out and back. In the arms up. Out and reach. In. Out and reach. In. And out. And shoulder circles. Back, up, in front, and down. And backwards. In the shoulders up. Out, let them fall down. In and up. Out and down. And the arms up. And reach always with one arm high up. legs wide apart, arms to the sides, breathe in, and out, go over to one side. In middle, out to the other side. Middle, and out, lean onto the knees. Breathe again in, out one arm front. In and back, out the other one in front. And back, and out, we're hanging down. Breathe again in. And out, go out one leg. Breathe in. And out over to the other leg. Again in. Out into the middle. And close the feet again. Breathe in. And out. In. And out, come slowly with a round back, up at the top, backwards, shoulder roll. The feet are standing a bit apart, the arms up. And out, sink down, elbows against the inside of the knees. Breathe in and straighten up. And out and come with the back up. Breathe in. Out and down. In and straighten up. And out, come slowly in one straight line up. Hands get down. Have a good standing leg, the knee of a mobile leg on top of the knee of it. Breathe in. And out and sink down. Up and change. And out and down. Up again. Legs to the sides, breathing down. And out, open the chest to the sky. In and up. And out. In and up. Out. In. Out. Breathe in and close the legs. And again out. That was the stretching. I thank you very much, and until the next time.